At the end of this lesson, you should be able to solve a system of inequalities by graphing. So the system of inequalities kind of combines system of equations and linear inequalities, the two rules with that, to create a system of inequalities. What I mean by that is you're going to graph each linear inequality, but you're only going to shade for your final answer where those two inequalities overlap, because again, that's the region now that'll work in both inequalities. So if you look at example 1, we're going to solve the system of inequalities by graphing. Y is greater than x plus 2. That's going to be this inequality here with a dotted line, because it's greater than, not greater than or equal to, and then it's all of the points above. All right, and then y less than negative 2x minus 1 is going to be the solid line and all the points underneath. The solution is where I'm going to shade here in red. Okay, this is the solution to the system of inequality. So all those points work. The points that do not work are all the points that work in both inequalities. So those are the solutions to the system. The points on the dotted line don't work, but the points here on the solid line here, those would put a true statement into both inequalities. All right, but the points on the dotted line there would not. So when you do your solutions to this, when you copy into your graphs, you're only going to shade where the two inequalities overlap. If your two inequalities don't overlap, like in example 2, if I graph all the points where x plus y is greater than 4 and x plus y is less than negative 1, notice there are no points that work in true, because you can't have 2 points when you add them they're greater than 4 and when you add them they're less than negative 1. So they have no points in common, so we would write this has no solution. Okay, so no solution if they don't overlap. Again, we're going to use Desmos as a tool to help us graph our system. When we go to transfer our answers or solutions to the system, we're going to only shade where the two graphs overlap. So let's do our boundary lines for this system. We're going to shade all the points where y is bigger than negative 1 and where x is less than 0. So here's the boundary line for y greater than negative 1. Here's the boundary line dotted for x is less than 0. But our solutions are just in this section right here. So there's all the points that work in both inequalities. So if I pick any point there, like if I pick the point negative 2, 2, negative 2, 2, so my y coordinate would be 2, and 2 is bigger than negative 1, and my x coordinate would be negative 2, and negative 2 is less than 0. So that point works in both. Okay? If we look at example 2, we're going to draw our boundary lines first. So 1, 1, and that's a solid line. So that would be our bottom equation here. Y is less than or equal to x plus 1. If we shade underneath that, that would be all the points where y is less than x plus 1. But we want to also include all and only include the points where y is bigger than negative 2x plus 2. So we graph that line. And we'll see that also goes through 1. That's a dotted line. And the only area we're going to shade is this area here. Those are all the points that would work in both inequalities. So, for example, if we picked this point here, which is the 0.21, and I'm going to show you how it works in both. Again, this is not something you need to do for your lesson, but I wanted you to see why those points work. So that's the 0.21. So I put in my first inequality. Let's see, y is 1, x is 2. So I get 1 is greater than 0 plus 2. Nope. Negative 4 plus 2. 1 is greater than negative 2, which is a true statement. So again, that works in the first inequality. And it also works if I put it in the second inequality. So if someone said, hey, list all the points that work, list some points that work in both inequalities, you just list points from that shaded region. So again, I'm going to put 1 in for y, 2 in for x, and I get 1 is greater than or equal to 3, which is again a true statement, so that point works in both. Any points on this little section here, they're on that solid line right there, would also give me a true statement because it would give me an equal to on the second equation. Whoops. Any points on the dotted line, however, would not, because those points wouldn't work in the first inequality. Okay, so you're going to use Desmos to get your graphs, and you transfer them over to your graphs. When you do, again, only shade where they overlap. If you get a problem where they don't overlap, then that system would have no solution. You don't need to graph it at all. You would just write the words no solution, and then you wouldn't graph anything. Okay, so if you go to look at Desmos and they don't overlap, then you wouldn't shade anything. So the problems you're going to do now are you're going to complete problems 3, 4, 5, and 6 after these, and then in the next section, problems 1 through 9.